Hey, this is a shortened video for going over question number 9. I'm just going to walk you through the steps, the process, so you can see the overall steps and process, and then you know what you need help with, and I'll give you advice for how to get help. So we are wanting to calculate the change in enthalpy for the combustion of methane, but in order to do that, we need to know the types of bonds. We need to know the balanced chemical reaction equation, and we need to know the types of bonds in the molecules of the reactants and products. So first step is to write out the balanced chemical equation for the combustion of methane. So methane is CH4, and in a combustion reaction, I'm reacting methane with O2, and it produces CO2 and H2O. So I know my reactants and I know my products. Then I go through the normal process of balancing, and the balanced equation for the combustion of methane is CH4, 2O2 goes to form 1 CO2 and 2 H2O. Once I have this, the next step is to get the Lewis dot structures for all of the molecules. So the Lewis dot structure for CH4 is this one here, and you can see that the types of bonds it has: carbon, hydrogen, single bonds. Lewis dot structure for O2 is this one here. And I don't forget to put the coefficient of 2 down because I have 2 oxygen molecules. The Lewis dot structure for CO2 is this one. And then the Lewis dot structure for water is this one here. So now that I have my, oh, by the way, and if you need help with the Lewis dot structures, remember in the Monday folder, those are the videos that kind of walk you through how to do Lewis dot structures. Follow those steps to help you. If not, you can watch a longer video of this where I model how to do the Lewis dot structures. Once we have that, then we do what we've normally done, which we calculate the change in enthalpy for the reactants using the number of the bond energies in the chart up here and the number of bonds that we have. So for methane, there are 4 carbon-hydrogen single bonds, each with a bond energy of 413. So 4 times 4, 13. And then here I have 2 oxygen oxygen and double bonds. Or sorry, let me back up. Sorry, I have 2 oxygen molecules, 2 O2 molecules, each with an oxygen double bond. And the energy of the oxygen double bond is 498, so 2 times 498. Add that together, I get the enthalpy, sum of enthalpy for the reactants to be 2,648 kilojoules. We do the same thing for the product. In the product, I have a CO2 molecule with 2 carbon-oxygen double bonds, so I do 2 times 745. And then here I have 2 water molecules, each having 2 oxygen-hydrogen single bonds. And so that means I have a total of 4 oxygen-hydrogen single bonds. So I do 4 times 467. And then I get my sum to be 3,358 kilojoules. When I subtract the sum of enthalpy for the reactants and the products, I get negative 710 kilojoules, and that means it's exothermic because delta H is less than 0. So that's a sort of overall process. All right, so if you need to see this whole problem done out, there's a longer video that shows you how to do all this. All right, I hope you found this video helpful. Have a positive day.